Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking, said I've been technically speaking, China white.
1.3, 1.4, and 1.5 of the CCNA prep course. We're going to go over 3 of these because these are really simple topics to explain. So I don't want to make it like a 10-minute, topic just for one. So I'm going to do a lesson with all 3 of these here, okay? And we're just comparing, we're just identifying, and we're just comparing, all right? Nothing too crazy. Remember to take handwritten notes. Get you a notebook, have it dedicated to learning the CCNA, have you a pencil or a pen, and write this down with your notes, okay? With your hand. Don't do digital notes. It will not stick to you, okay? So as we get into 1.3, we are discussing different types of cables in the network, and there are 2 different types. Ethernet and fiber optics. Ethernet transmit data through electricity. Fiber optics transmit data through light. Light is faster than electricity, okay? Ethernet cables, we used to call them copper cables back in the day. They kind of still are called copper cables because they have copper wiring, but that's more of an old school term. You really just hear Ethernet cables. They even have Ethernet fiber optic cables, right? So they've been doing a lot as technology advances. Just going back really quick, just showing you what the Ethernet cable looks like in real life, which we've all seen. And both of the ends of an Ethernet cable look like this, right? And they either going to be straight through or crossover based on the wires inside of that cable, right? So this cable, you see how this has a blue cable link? That has nothing but a whole bunch of copper wires that's either been twisted together. Well, they all actually have been twisted together. We call that twisted pair. And then we have an untwisted pair. I think twisted pair is more common and what's been used since, for the past 30 some years. So within this, tube here, there are copper cables that's been twisted and added a nice layer so you can't just easily break it or easily break it or easily make it deteriorate. It'll do it over time. This clear thing above, well, on top of that blue tube is called a RJ45. Capital R, capital J, dash 45. That's the type of connector this is, right? So you'll probably have to push this little lever thing down and plug it into the wall or plug it into your computer or whatever so you can get the signal. This RJ45 has 8 pinholes in it. And that's so these copper cables can come out. They're really small. If you have an Ethernet cable around you and you don't really need it, I honestly think you should probably get it and try to rip that RJ45 connector off so you can see the small little cables, the little wires, right? So these wires right here come out, they're color coded, and this is the diagram that they use. Straight through or crossover. Straight through is for connecting unlike devices. And crossover cables are for connecting like devices that are the same. Straight through is connecting devices that are not the same, right? So a switch and a router, those are 2 totally different devices. So which type of cable do you think they will need? they will need a straight through cable. Exactly. Ding, ding. Okay. But if you want to connect a switch and a switch or a router and a router, then you would need a crossover, right? All right. Don't want to go too far into it because they may ask one or two questions on the CCNA. If you get these questions wrong, it's not going to kill you, but it's good to know this so you can make sure you get it, as many questions that you can write, but also so you can have the knowledge when you go out there. Because believe it or not, no one cares about the education that you got, whether it's from a school or a cert. They just want to know, do you know what you're talking about? That's how you get the money. So as we keep going up, this article is really good. It basically just has the information. I'm going to send that to you guys just so you can have it, review it. It goes in some more, but I definitely just wanted to show you the Ethernet cables and how they transmit data, which is through electricity, which is through these copper cables. Okay. Now, if you want to go deep dive, because that's what I did, I deep dived into this when I first was started. And if you deep dive, you go all the way back to Morse code and how they use electricity and copper to do the dee, 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 right? And that was the first line or first invention of communication, right? I believe that was maybe Alexander Graham Bell who discovered that. I don't know. Don't get me the line. But one of those folks came in, discovered that you can transmit signals through electricity. All you need is copper. And so he did that, and boom, as technology advances, we are here today, right? So it's pretty cool. You probably should deep dive into it. I think I wrote a blog on it when I was with my first contract. So I'll probably give that to you guys later. But going in, we now know about Ethernet, right? Now, fiber optics, because we have single mode fiber and multi-mode fiber. Now these, again, fiber cables, fiber optics is transmit through light. Now, single mode just means that it's a strand of light, one strand of light, or you can say, what we say is glass fiber, right? One single strand and supports one mode of transmission. So one mode means either you're going to send or you're going to receive, okay? You can do both, but right now, single mode is you need to choose which one you're going to do, okay? So in this long cable that has light, it has a glass, and then the light is shined through that glass, it's either in single mode, it's going to be one strand. And that one strand is sending, let's just say it's sending data, right? It's not receiving anything, it's just sending it. But then we have multi-mode, right? Multi-mode is you can send and receive, and in one cable, right? In one fiber glass, you can say. And multi-mode is used for smaller distances because it's a lot going on. Single mode, you can, pretty far distance. Because as you start spreading out the resources, you can't have all of these different types of caveats. We need one thing at a time. And that's even something in life, right? You got to do one thing at a time. In order to succeed, you can't succeed by multitasking. You can't succeed by, saying you're going to learn cybersecurity, then doing Net Plus, and then you're going to be a software developer. That's not how you're going to succeed. You're going to succeed by doing one thing, hyper-focus for a set period of time. That's single mode, right? It can long distances, is great, right? And it's going to send really great data really fast, but it only can either send it or receive it at a time. Okay. Multi-mode, I mean, you can send and receive, but it's not going to be a long distance. It's going to be quick, smaller distance. Okay. So when we talk about compare and contrast different cabling types, you want to think about two different types of cables: Ethernet, transmit data through electricity, and fiber optics, transmit data through light, okay? Fiber optics have a single mode, which supports one mode of transmission over a long distance, and multi-mode, support multiple modes of transmission over a small distance. That's really important for your exam, okay? Multi-mode, smaller distance, multiple modes. Single mode, long distance, one mode. That should be what you should be writing in your notes. Okay. And then they'll probably say copper cables, which is Ethernet cables, right? May or may not ask you about straight through crossover, but we will do more and more as we continue on, so you can kind of get that ingrained in your head. Now, moving on to section B, connections. Compare the connections. They want you to compare an Ethernet, shared media, and point-to-point connections. Okay, Ethernet. Now we have the internet standard. We call the folks that create standards for the internet, standards that we use, period. It is the IEEE. They're like the electrical engineering something. I forgot what it stands for, but it's like Electrical Engineering Institute of whatever. These are the folks that create our standards. So even if you're not knowing networking, maybe if you are in DevOps, or if you're in development, or you are in some other realm of dealing with technology, you will see IEEE. If you are really big fans of blockchain, you may see IEEE. Why? Because these people create our standards on how we communicate with each other over the world. Okay, cool. So you will see IEEE all the time. IEEE has a standard called 802.3. When you see 802.3, that means Ethernet. When you see Ethernet, you should think of 802.3, something you should write down, okay? 802.3 is the standard of how we are supposed to use Ethernet according to these internet police folks, okay? In simple terms, in this here, it's technology for connecting devices wiredly, right? Wired in a wired setting. Again, it's connecting through these Ethernet cables to a computer, to the switch, a computer, to the router, whatever, as you can see in this picture here, okay? Shared media, right? It's exactly what it sounds like. A media that is shared. What media that's shared? It can be a switch, a router, a hub, something that more than one device is connected to because we're sharing this device, this media, okay? Now, each time we connect into a device physically, it is called a collision domain, right? It is a domain that has collisions. So if I connect to it and you connect to it, and we're both trying to access the internet at the same time, hey, something may happen. I may get to a connection faster than you. You may get to the connection faster than me, right? Because we're sharing the same domain, which could have collisions, right? We'll go in more about collisions because I don't want to talk about what is colliding. The data's colliding, but that's too high level. What's really colliding is the packets, is the frames. You guys don't know about what packets and frames is, so I'm not going to go too deep into it because we have a whole nother lesson on that. Just know that shared media equals collision domain. It equals a domain where packets or data can collide. I did put here CSMA/CD. Now, I don't know if you guys remember, but way back in the day, we had our cell phones, and our cell phones could not get on the internet.
In today's fast-paced world of technology, staying ahead of the curve is essential for success. But with the ever-expanding landscape of IT certifications, mastering the right skills can seem like a daunting task. Introducing Tech Exam Mastery, your ultimate solution for conquering IT certification exams with confidence. Whether you're aiming to become a networking guru, a cloud computing expert, or a blockchain innovator, Tech Exam Mastery has you covered. Our meticulously curated notes provide in-depth coverage of key concepts, organized in a clear and concise format, saving you time and effort in your exam preparation. Join the thousands of IT professionals who have unlocked their full potential with Tech Exam Mastery. Accelerate your career growth, expand your skill set, and boost your earning potential. Don't just adapt to change, lead it. Tech Exam Mastery. Comprehensive prep notes for IT professionals. Click the link below to learn more.
and talk to someone at the same time. You had to choose. Either I'm gonna talk to you on the phone or I'm gonna be on the internet or send you a text message. We couldn't do it. That was CSMA/CD technology, right? We don't do it that technology anymore because we can surf the internet and talk to you and be on FaceTime and send a message. Like we can do it all. There's no collision domains that's gonna stop us. But when you think of collision domain, when you think of a shared media, you think of this old technology, right? This technology, and it's really honestly not that old. I mean, I guess if we're thinking about, let me see, what was it, around maybe 2005, maybe that was the technology. Maybe even 2008 or 9, that was that technology. I don't know. When was I able to talk and text on the phone? Maybe 2010? I don't know. But I mean, 20 years ago, I guess that's old, right? And another keyword is hub. Now we'll talk about switches and hubs and stuff, but really quick, a hub is just a switch with no intelligence. We talked about switches in our earlier lessons, and we said a switch has intelligence that know how to switch traffic around, how to move traffic in your local area. But a hub does not. A hub just says, oh, you want this? You sent this to me? Okay, I don't know what to do with it, right? This was an early invention of the switch. We'll talk about the history of that later, but just so we have a keyword hub and you can kind of know what that is. So yeah, shared media, old technology, collision domains, you know, our data is going to collide at some point. And the circle with the 1 in this diagram, and we have a little oval with the 2, oval with the 3. These circles indicate collision domains. Okay, so you see 1, that's a whole collision domain in itself. And then 2, and then 3, and then 4, these are all collision domains. Now, this is a hub. So that's why it's not just on each point, it's on the whole thing. Why? Because a hub has no intelligence. The whole thing is a collision domain. Once you send some data to this hub and then someone else sends data to this hub, the hub's like, oh my gosh, I don't even know what to do. I'm getting so much data. And then stuff is going to start dropping. You probably won't even get to the internet. It's so terrible. No one uses a hub unless it's for redundancy. Okay. A switch has collision domains at each port, at each little point. So as you can see, this switch has 1, 2, 3, 4 collision domains, right? So the switches became a little more intelligent. So they're like, hey, we got separate collision domains. And then of course, a router is going to be the same, separate collision domains. Now, the next one is point to point. Point to point sounds exactly what it is. It's from one point to another. That's the connection, okay? I'm going from a switch to a router, from a switch to the hub, from the hub to the switch, from the computer to the switch, from the computer to the router. It's just point to point, right? Nothing fancy to it. That's all the connection is. You see this a lot in, I guess, in more of a WAN, wide area network type of ordeal, because it's pointing to more of a large type of I guess setting. We'll get more into point to point because we're going to actually talk about different ways we route in the internet. But for right now, you just need to understand that there is a connection called point to point, and it's just as simple as that. It's from one point to the next. Okay, a switch to a router to a switch, whatever. Okay, 3 connection types. Make sure you understand Ethernet, 802.1.3, 802.3. Excuse me. Shared media, hub, CSMA, CD, collision domain. These are kind of like some of the keywords you just spew out. And then point to point, switch to router, router to switch. Moving on, PoE. We talked about PoE, so don't really have to go too much into it. It's power over Ethernet. In today's devices, they come with PoE. I guess when you think about 10, 15 years ago with technology, I guess it's drastically different. I guess if you're like a millennial like myself, then you've been through all the kind of like elevations of technology, or the evolution of technology, which we had the Y2K. Oh my gosh, the world's gonna end because we were switching over from analog to digital, right? Maybe when you were younger, my grandma had the rotary phone. Like we had to dial 7 and round that thing all the way around, you know. I remember, my grandma ended up getting a digital house phone, and I didn't have to put the area code. I could just put, especially if it was local. I'm from Atlanta, Georgia, so I didn't have to put 770 or 404. I can put, just the 7-digit telephone number and it will route, right? And then we had to put the 10-digit number. And then cell phones became a thing. I had the Nokia, right? And if you want to text, you had to press that number 3 times to get to the C, right? So I guess, you think about 20 years ago, 15 years ago, it's, pretty advanced. And PoE is a new technology when you're thinking about 10, 15 years ago. And PoE just gives you the power over the Ethernet, okay? Most switches and routers come with that, and they know exactly how much power this device needs in order to power up. But we're engineers, so we can say, hey, give this device this much power. We can actually, this is the static assigned power to devices. Static means that I'm setting the amount of power. I can say 14 watts or 23 wattages or whatever. We'll get into that. Maybe we will, maybe we won't, because wattages are more on the voice network side, and this exam is not for voice networking. It's just for basic networking. But you can assign it. So that's PoE. Again, we talked a lot more about it last class, so no need to go too in. And then that is 1.3, right? Simple. Compare physical interface and cabling types. And then they tell you what they want you to compare. They want you to compare single mode fiber, multimode fiber, and copper. They want you to compare the connections of cables. And the connections are Ethernet, shared media, and point-to-point. Then they want you to compare, or they want you to know the concepts of PoE, which is just power over Ethernet, which is the switch or the PoE device will send the needed amount of power for the device to power on. Or you can be an engineer and assign that power, the amount of power to the device by going in and saying, send X amount, okay? So that's 1.3. Now, let's go on. What's after 1.3? We have 1.4, identify interface and cable issues. Let's go to that. So 1.4, we kind of talked a little bit about it, which is the collision domains. They tell us already to talk about collisions, errors, mismatch, duplex, and speed. So let's talk about each one. First one, collision domain. We went in on it. We know it's a domain that has collisions, okay? So a hub is the whole hub is a collision domain. A switch has collision domains at each port. So each one person gets a domain. Am I going to collide with my own domain? I could, but it's very rare. And if I do collide and something's happening, for instance, my internet speed is slow, or the web page is not loading, or I cannot make or receive phone calls, I know that I could check your port. I could check your interface, AKA your port, right? Which is the little hole. And I can see, like, is it you? Are you having collisions in your domain? For what reason? Could be a myriad of reasons, but at least it's easier for us to troubleshoot and faster for the user to send and receive data, i.e. get on the web page. Now we have mismatch duplex, okay? What is a duplex? Now in computer networking, duplex refers to data being sent and received at the same time. So when you see the word duplex, think of sending data and receiving data at the same time. So a duplex could be full, which is sending, receiving at the same time. It could be half duplex, which is one send or one receive, or it can be auto. Auto means that one side of the point-to-point connection is this duplex, or let's say it's half duplex, and the other side will automatically match the other end. So let's say, for example, we have a hub and we have a switch right here, okay? Well, it kind of gives you already. We have our half duplex and we have our full duplex. Now, we could have mismatched duplexes on each end, as we can see, half and full. And what'll happen? Data may get slow. There may be no data getting sent through. It can cause some issues. So what we have to do as the engineers is go into our switch, go into our hub or our router, whichever device, and take a look at the duplexes. That's one troubleshooting step you can do, and say, hey, is this half and the other end is full? If that's so, it's mismatch. Maybe you should make one side the same as the other side. I don't know, pick half, pick full. It's up to you in your troubleshooting to know which one you should do. But just know that that could be an issue, and that could be a troubleshooting step that you do while you're trying to resolve an issue. Because again, we're network engineers and we get tickets based off of the network, right? We only work when something's messed up, not when something is working, obviously. So they say, hey, something's going on. That's one of your troubleshooting steps, mismatch duplex, okay? Then we have our speeds. Our speeds, you probably hear, we have it in MBPS, which is megabits per second. That's what that stands for, the speed, okay? And if the speed is mismatched, it can have some issues as well. We want to make sure that the speed is set to what it is. It's usually, in my experience, 10, 100, or 1,000. And this is also on the exam as well. They only give you 3 speeds. It's either 10 megabits per second, 100 megabits, or 1,000 megabits per second. So if you are in charge in the household of getting your internet, whether it's from AT&T, Comcast, or Xfinity, you might want to look at the speeds. They may say fast speed, but what's the megabits per second? Because they'll say fast speed and say it's 10 and say it's 100. You'd be like, well, that ain't nothing. The fastest speed, what I have Xfinity, I think, or something. And I have 1 gig. So obviously it's faster than all of this. And that's what you want to pay for. You want to pay for really, really fast data transmission is what we call it, okay? So when you think of speeds, think of it in these kind of simple realms, 10, 100, 1,000 megabits per second. We will talk a lot more about megabits because how we talked about electricity and light transmitting data, right? It's transmitting data in ones and zeros. You know, I don't know, maybe you guys seen the Matrix? I hope you have. Everybody's seen Matrix, hopefully. And in the Matrix, they have a bunch of ones and zeros behind a black screen, and the ones and zeros are green, right? That's computer language. Ones and zeros, ones and zeros. Those are called bits, okay? And then 8 bits put together is a byte. So you may see bytes, B-Y-T-E-S, right? And then you may see megabytes and then kilobytes and then gigs, gigabyte, right? I don't know. I think that's like a, I don't know. Don't give me the line. Just know that it's, it's a lot, all right? But bits is the bare bone of the computer language, ones and zeros. We will go in on that because we have to learn that for the exam, but it's not in this lesson. I just want to, get you to understand where we get the megabits per second. Is how many it's sending. It's sending 1,000 megabits per second. A bit is 1 or 0. Okay, so when you go out and you start seeing all these little acronyms here, you'll know what they stand for. You'll know what it means. You'll know how to identify it from a basic level. And this is what this exam is for. Give it to you in a basic level, right? Again, this is a lot of information. We're taking it step by step, but you said you wanted to make 6 figures a year. You said you wanted to be financially free. So we have to learn the technology or have the knowledge that no one else is willing to learn, right? Is we don't really, I don't do much math. I'm terrible at math. I failed math every single grade. So it's not a lot of math in this, but it is a lot of knowledge that you must have. And it's okay, it comes over time. So no fret, but just keep pushing, right? That's why we do handwritten notes. Next is the errors, right? Errors is kind of what I've been talking about through the collision and the mismatch duplex and the speed, right? What errors are we talking about? We can have slow speeds. You are an engineer, you sit on the clock, right? You sit at home on your computer, and you probably, well, everyone has a ticketing queue, and everyone gets assigned a ticket. We all got to do our part to clear the queue out. And a lot of the tickets in the queue is about slow connection, no connection, sometimes a connection here, sometimes not a connection, you know, it's usually all about something with connection. So with these errors, we want to figure out what could be the issue, right? And it could be for a variety of reasons, right? Like I could go in, but we need to understand that we need to check our speeds, our collisions, our duplex. Now, as we talk about packets, a packet is what holds our data, right? And in this packet, they have where they check errors. So as a hub sends data to a switch, it's going to send data in a form of a packet, right? Again, it's nothing but ones and zeros. That's all it is. We just call it a packet because it is more than just a 1 and a 0. It's a bunch of ones and zeros put together. Now, this packet that gets sent, this packet has what's called a frame check frequency, FCS, and it will automatically check errors because, again, they want to make sure that no hacker, there's not no malicious packet or malicious data, all these things. So when it comes to errors, it could be so many reasons. But we want to understand, first, we want to make sure that we understand speeds need to be the same. The duplex need to be the same in the collision domains. Are there some collisions going on? And then let's say everything is checked, but we're still slow speed, still no connection. Then we would have to keep going, keep digging. Digging could be the Ethernet cable. Maybe the Ethernet cable trash is old. Somebody been putting stuff on top of the Ethernet cables or something. So, or they've been like snatching it out the wall. So now it's messing up the transmission. So let's go get another new Ethernet cable. It could be the port itself. Maybe that port's not good. It could be so many things, honestly, right? But we want to at least understand where to check. And that's basically the errors. Okay, cool. That's 1.4. See, not that bad. Let's go into last lesson. 1.5, compare TCP and UDP. We kind of talked about this earlier, but we'll go in a little more, okay? So TCP UDP, this is protocols. These are protocols that are on the transport layer of the OSI model. We talked about the OSI model, but let's just look at it here. We have our physical layer, data link, our network, our transport, which is layer 4, and then we have session, presentation, application. Now, this is the OSI model, pretty used widely. We also have the original and the updated TCP IP model. This is before the OSI model came into play. And what they did is they basically just made the whole application layer, layer 8, layer 7, and layer 6, session, presentation, application. And I remember when we talked about it, session is how long you have access to this type of data. Presentation is how the data shows up. Is it compressed? Is it encrypted? Is it JPEG? Is it movie or something? I don't know. Is it PDF? Is it PowerPoint? Is it Excel? Is it CSV? Like, you know, or yeah, CSV. Right? And then application is the app that you're using. Is it a Gmail? Is it Trello? Is it iCloud? Is iCloud an app? I don't know. Is it Notion? Is it Discord? Right? Is it Microsoft Teams? That's an application. So they kind of, in the early terms, they just push all that together because as a network engineer, we don't care about all that. Okay, I don't care about application, presentation, session. I mean, we care if you can't view a file and it's like, well, it's compressed. That's why you can't open the folder, right? But that's not for us to really know and care too much about. We care about the physical, the data link, the network, and the transport. And the transport is a lot of different things, but it really just boils down to TCP and UDP. All right, let's talk about TCP. TCP is Transmission Control Protocol, right? It is a protocol that is connection oriented, meaning that it has to make a connection with the receiver. The sender has to make a connection with the receiver to ensure, like, listen, I'm about to send you some data. Are you ready to get this data? And I need you to tell me that you're ready to get this data so I can send you this data. That's really all it's saying. We call that a three-way handshake. As you can see in this diagram, the sender sends a synchronized message to the receiver, like, hello, are you there? And then the receiver sends a synchronized acknowledgement message to the sender and say, yeah, I'm here, what's up? And then the sender sends the acknowledgement back to the receiver and says, I'm just gonna send you some messages, okay? And then boom, then the sender starts sending the real data. Now, this happens in a millisecond, so it's not like, oh, I gotta wait till my computer makes a three-way handshake with, no, it just automatically, go ahead and Google something right now and watch it pulls up. That was the three-way handshake, right? So it's more reliable data. It doesn't matter about speed, right? So it may not take a millisecond, it may take a full second, right? And believe it or not, that's too slow. Okay. And as you start to advance in your career, especially on the tech side, you will see how important speed really is. And in 1 second, a company could lose millions of dollars. Okay. I know I've made the company lose millions of dollars before because the server was down. Anyway, that's a story for another time. But just know that speed is very, very, very important. But with TCP, reliability is more important than speed, okay? Making sure that data gets to that person. I don't want HR to know that I'm talking about Sarah, okay? Now, we have UDP, which is the opposite of TCP. UDP stands for User Datagram Protocol, okay? It is connectionless, all right? The sender don't care about the receiver, okay? The sender's just like, hey, I'm about to send some stuff and just start sending it. They don't even warn the receiver. They just start sending it. Hopefully the receiver gets it, you know? So we would, and UDP is all about speed instead of reliability. I don't care that you got it or not. This data went fast, all right? So it has some pros and some cons. Now, for certain different types of technology, we use TCP and sometimes we do UDP. UDP is really big when you're thinking of broadcast. If you want to send everybody a message, let's say a child got abducted and they want to send one of those child alerts, those Amber Alerts, it's a broadcast, right? Who cares who got the alert? But everybody, I'm sending to everybody right now, real quick, right? That's more UDP. But TCP is more like, an email, because I want to send it only to you and not to my mom, okay? UDP, we use it a lot in voice networking. So with voice networking, we're sending audio, like my audio over this Zoom right now would be UDP, right? It's not saying, oh, let me make sure that you get every single word I'm saying. That's not what Zoom is saying. Zoom is like, hey, you on this call and it's getting broadcasted out. Hopefully you get what I'm saying, right? It's important to, I guess with voice, it's important to just send it out in a broadcast way because audio cannot be resent. If I say, hello, how are you? Hello, how are you needs to be sent to you fast as possible, just like that. Instead of saying, oh, you didn't get hello, let's just say how. Oh, you didn't get R, let's just say you. So now I'm saying how you, and you like, whoa. Or I'm saying you, and you like, I didn't get hello, how are you, right? Because TCP is trying to make a connection, and if the connection failed for any reason, they're going to resend that data. I don't need you to resend hello, how are you jumbled up.